This is the fourth in a series of videos on the subject of configuration management, designed to provide a grounding in the subject and to allow those of you who are either about to start doing development or have recently started to understand what it's all about and how important it can be to projects. In our last video, we looked at development and version management, and how modern CM tools can be used to handle teams of developers writing code and resolving code conflicts. It is time to look at how we build the project as part of an automated build process. Probably the first question you might ask is, why should we build the product in an automated process? Why not just let one of the developers build it whenever it's needed? Once upon a time, that is how software products used to be built. However, if you have a team of developers, depending on which of them compiles the binaries or prepares the release files, it might not contain everything that has been compiled. Or worse still, might include something not intended for this release. Modern software engineering has transitioned to automated build systems that operate independently from a developer's local machine to ensure consistency. We need to look at the essential project metadata required to manage this process, focusing on the high-level identification and versioning of a product. There will be a structured framework for tracking individual deliverables, including their source locations, file types, and specific interdependencies. By monitoring the real-time status of these components, teams can oversee the transition from initial compilation to final quality assurance. Ultimately, these guidelines provide a blueprint for maintaining a rigorous control over the entire deployment lifecycle. Like all processes, software development has evolved over the years, and each evolution has removed one or more problems. Compiling and preparing a release is now usually done within computers separate to those of the developers, and takes all of its input from the version management and requirements or issue management systems. So let's have a look at our product and see how it is configured. So what metadata is stored on the project or product? What is the project or product name? What will the published release version of this product be? What is the build version of the product, as this build version auto-advances with each attempt to build? What are the deliverables of this project? For each deliverable, what is the version of the deliverable? What kind of build is this? Is it a SQL database, an executable, JavaScript, or documentation? Where are the files in the version management system? Which branch of that system are they coming from? Where are the output files to go from the build? Is this deliverable dependent on another deliverable, giving us a build order? What is the state of the deliverable? Is it unbuilt, currently building, built, or having failed a build? What is the state of the project or product as a whole? Is it unbuilt, building, built, failed, passed to testing, tested, or failed testing? Before we look at the actual building of our product, we need to review our gatekeeper processes. When developers check code into the version management system, they should have unit tested it first. Therefore, anything you can do to check what's being checked in, to keep out untested code, is a bonus. For example, one common check on SQL scripts is to attempt to parse these scripts automatically as part of the check-in, before the version management system has been updated. Any SQL script that fails a simple parse has its check-in refused. This traps syntactical errors which by their very nature prove that the code cannot have been tested. As each file being checked in has a mandatory reference to the requirements management system, and these requirements management entries have a status, then 2 further checks can be performed. The requirements management entry provided by the developer during check-in must exist. Secondly, the status of the RM entry must be in development. Checking in a source code change to a requirements management entry which has already completed development is pointless. If either of these checks fail, then the file being checked in is rejected by the version management system. Now we move on to builds. There are 2 kinds of builds we will look at: planned builds and continuous integration builds. We will look first at planned builds, where a decision has been made to enact a build process. The requirements management system holds a list of all the items for the product's deliverables, and which have been marked as development complete. This allows a report to be generated listing all the items that could be in a build and the associated files. This report will allow the team leaders, Scrum Masters and Project Managers to determine if enough work has been done to justify a build candidate. The build management system will then determine the deliverables in the product and trigger dedicated build computers to extract the appropriate files from the version management system. Spreading this load across multiple computers, ideally virtual ones with a controlled configuration, will allow the build to progress in parallel where possible. When all the deliverables have completed building, a summary report is generated listing all deliverables and their current state. For example, did any of them fail to build? With links to error logs for those that did fail. Whichever manager triggered the build can then, if warranted, amend the state to passed to testing, to notify the testing team to pick up the build and test it. Not all successful builds will go to the testing team, as a build may be performed to check that everything can be packaged correctly. Continuous integration builds. These builds are done for the purpose of a sanity check on what's been checked in to the version management system. For example, if you are a developer and you check in 20 SQL scripts, this could trigger a build of a database, combining your 20 updated or new files and all the files already in the version management system. The result of the build is notified and you can take action to fix any issues. CI builds executed at check-in time can be problematic if you have large numbers of developers and their files or code objects that your code depends upon are not yet checked in, giving premature errors. As developers will be checking in throughout the day, it also may stress the build system while performing constant building. What you are more likely to find is a CI process that runs once or twice a day at fixed times, allowing developers to see what is or isn't working. Preparing for testing. Once a build of your software product and its deliverables has completed, and the decision to pass it to the testing team has been made, the project metadata is updated to mark it as passed to testing. In a modern set of configuration management tools, this prepared build can then be worked on by the testing team, while the development team can then move on to work on the next time box of work. In the next video, we'll look at the job of the testing team and what happens when they find faults with the build you just gave them. But that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.